Okay, everybody, this is Aaron Murakami. It's 11 o'clock Pacific time on Sunday, April 10th, and we have Eric Dollard on the call with us. Can you hear me okay, Eric?
Yeah, you're going to have to try to speak louder, so we're closer to the phone.
Okay, I've got the microphone real close.
Might be time for a new microphone.
Yeah, I think this might be going out. So we don't have any particular topic planned. There's only a handful of people on this call. I guess first of all, Eric is going to be presenting at the 2016 Energy Science and Technology Conference in Hayden, Idaho this summer. If you want details on that, that's at energyscienceconference.com. And then Eric's homepage is ericpdollard.com. And if you want to support Eric's work at EPD Labs, you can make a donation through PayPal there. And there's an address where you can send checks or money orders if you want to support the nonprofit. Do you have any announcements first, Eric? Or
no.
Okay. Let's see. Well, we only have a handful of people on the call here. If you do want to ask a question, just hit 5** or 5*, and I'll see a little flag that tells me you want to ask a question. Okay, let's see. I'm going to hit this little button here, and you're going to hear that your hand is being lowered, and then go ahead and introduce yourself and ask your question.
Hello?
Yeah, go ahead and speak up, and you go ahead and introduce yourself and ask your question.
Hello? Can you hear me?
Yes.
Right, okay. Hi, this is Michael Rieger. You might know me by the name of Sputins on the Energetic Forum from a post there occasionally.
Okay. What is your username?
Sputin.
Okay.
I'm from Australia, and it's 3 o'clock in the morning at the moment. Anyway, I have a question on the Crystal Radio Initiative. Can one use your 20% height to width ratio coil that's, say, perhaps designed for 2 megacycles or a higher frequency, but use that for a medium wave AM band and just load it up with a little bit more terminal capacitance and a variable air capacitor across the secondary coil that are tuned in to, say, a lower frequency such as 891 megahertz, kilohertz, for example. Did you hear my question?
Yeah, I'm not quite certain what your question is, but what I'd say is it's not a good idea to load the coils down. They lose their transmission properties. It's better to actually have the right number of turns. You will get some results, but the burden on the coil will just turn it into a parallel circuit, and it won't want to communicate outside of itself.
Okay, that's kind of what I thought. Yeah, you don't want to burden it down too much, so it's better to build a new coil for this.
Yeah, that's what's really critical, because there's no way to directly calculate it. So you have to kind of get in the ballpark and then experiment to find out what kind of burden the insulation is going to provide, and the external impedances that it's connected to and all that are going to really drastically alter the frequency. So there's a little bit of fooling around involved to get it so that you optimize the thing, but the least terminal capacity and the less inductance you have in the neutral lead connecting to the Earth, the more effective the coil is as a transmission device.
Okay, correct. Okay. Well, that's another thing I'm working on is the neutral terminal lead to the Earth. So I've got lots of fine conductors at the moment, like about 8 or 12 of them. So, from a span of about a few meters to the ground rods. So I know it's better with sheet copper, but that's about all I can work with at the moment. So I just finished that today, so hopefully I can try and tune something in the next few days, but I might have to build a new coil yet.
Yeah, the ground system's pretty critical, so you want to try to approximate some kind of conductor sheet the best you can. So a number of wires spaced several inches apart. At lower frequencies, will approximate using a copper sheet, and then the ground rods should be as far apart as possible, and then zigzag between them a bunch of cross-tie wires, and then bond and solder all those together to kind of give yourself a sheet. It's actually best if the coils sit right in the middle of that ground configuration.
Right. Okay.
The less wiring you have between the coil and the ground, the better, because that inductance in the ground lead is just as detrimental as extra capacitance on the voltage terminal at the other end.
Right. Okay. I understand. Also, with the frequency of, say, I'm reading some of Tesla's notes and so forth, he says that for the optimal frequency for sort of ground transmission is sort of 25 to 50 kilohertz, and that 1 megacycle or the sort of the AM radio band would be a little bit high and maybe not as efficient as if it were lower. So I guess
yeah, well, the thing is, you're not really trying to duplicate, Tesla's larger stuff, because that's pretty difficult. So Colorado Springs, that operated, I don't know, you'd have to go back to what I wrote on that or go to this notebook, Colorado Springs notebook, but I think it was about 50 kilocycles, which actually is kind of high for that endeavor, but it's hard to say because Tesla was after exciting specific harmonics in the interior of the Earth and certain modes of harmonics, and he really didn't provide much information on that, unfortunately. So we don't know what kind of mode he was trying to excite. We don't know if he was just sounding the Earth or if he was actually trying to transmit somewhere. That's the unfortunate thing about dealing with Nikola Tesla, is there's no real information to work on. So it makes it a difficult task for the beginner to figure out what's going on, because there's all these exotic considerations and calculations and what have you, but lengthy experiment will usually land you where you want to get.
Right. Changing the topic slightly, I had a question on J.J. Thomson's electromagnetic momentum, which you've spoken about, or lines or tubes of force terminating on objects to produce the inertia and so forth, or under that theory. And you said, so at one point you hinted that using a Tesla apparatus, or your TMT, you might be able to kind of ground into counter space, as to find some sort of universal grounding point. Do you have any further thoughts on that particular idea?
Well, I kind of don't quite get how the grounding ties in with the electromagnetic momentum, but the thing about Tesla's apparatus is it establishes a self-referencing condition where it doesn't need to be grounded as a reference. You can't do, because the ground is the output. So what Tesla seemed to have accomplished was establishing a network in the form of a coil that, when it was proportioned properly, it self-referenced, it grounded to another dimension, use the words of physics.
Right, okay.
Go ahead.
It kind of reminds me, there's a story, and it is just a story, and you probably wouldn't have heard of it, and it's probably a load of rubbish, but there was a story about a Joe cell, which is basically a water capacitor running in a car. And the occupants, suddenly didn't feel any inertia when they went around corners, and some other really strange stories. And I thought, well, maybe that particular cell, the way it was configured, may have had something to do with kind of a universal grounding point. And that,
that would be what you would have to. What you're going to have to do to get rid of the inertia is there can't be any potential differentials between the object that you're trying to get rid of the inertia on and the surrounding environment. In other words, there can't be any lines of force attached to it. So that means that you have to raise that object or lower, or however you want to look at it. You have to make its potential exactly equal to the potential in its surroundings. So in order to establish that potential, you would have the same situation you would with the Tesla transformers. You'd have to have some kind of self-referencing condition because you can't connect to anything external. So what we're really talking about is another type of electricity here that's monopolar. It's a single phase rather than a two-pole or two-phase. The word single phase is used erroneously because the system phase number is the number of active conductors other than the neutral. So you always have to have two wires minimum, so you always have to have two poles or two phase. But Tesla's transformer creates a single phase alternating current. In other words, there's just one output terminal, and that's the neutral and the coil that connects to the ground. So according to J.J. Thomson's idea, if you were to render something inertialess, you would have to ground your generating device to some other dimension, for the lack of a better term. That's the difficult part here, because there's no real understanding of that.
Right. So I don't know, maybe that water capacitor had something to do with it. I don't know if you know about much, to do with what water is about, but do you think that maybe there's some kind of a connection with the ether through the medium of water or its component parts, such as hydrogen or oxygen?
It's really hard to say because, you hear these stories, but there's not really any details. So basically, all you can do is speculate. And then a lot of times you have to wonder if the stories are even true. So it's pretty difficult to try to engineer something like that.
Yeah. I guess another just basic question, what have you been doing lately as a general question?
Working on my presentation, or trying to anyway, amongst the various complications that I have to face in order to keep everything intact here. So these presentations take about 4 months of intensive work. So that's basically what I'm working on all the time now, is to get this thing assembled and ready to go. It's really an overwhelming task. But I'm moving forward, and it looks like I have a general plan of presentation. So this one's going to be pretty theoretical. It's not going to be out there. It's not going to involve Caesar differential equations or anything of extraordinary complexity. It's pretty much going to be Ohm's law and algebra all the way through. The aim is to show how to develop what's called the analog network or analog computer, where you can simulate various coordinate systems and dimensions in electrical transmission with networks of coils and capacitors on the bench, and then study these propagations in this analog form with an analog computer, and then later attempt to apply them to actual transmissions through some kind of medium or free space.
Okay. Very good.
Basically, what I'm trying to do is lay the groundwork, a mathematical justification for the longitudinal electric wave. That's primarily what I'm after here. Starting with the conventional type of wave, which is fairly well understood, and then, as the term I use, going through the looking glass and getting over to the other side and dealing with propagations that are very little understood, but are the basis for all of Tesla's and Alex Anderson's transmission work.
Right, I understand it's kind of heart of your earthquake detection system. guess one of these days I'll have to get over to America and see one of your conferences, but I don't know if we can afford it this year, but one of these days hopefully I can.
Yeah, well, at least they're recorded, and the amount of material involved and the complexity of them, it's usually the recorded version that's going to be the most useful, because you have to kind of sit down and watch things and take notes and and go back and review, and then usually I try to put out a book that corresponds along with it, but these books are rather lengthy, and the amount of work it takes to put them together and get them published and all that is really almost it's just overwhelming. It's almost impossible to pull all this off.
Well, I'm sure it is. I suppose we can probably move to someone else for some other questions, but I'd just like to say that, your work has greatly affected, I suppose, my whole direction in life at some point, and so thanks for that, and just so you know, you are affecting people around the world with what you teach, and your works have really meant a lot to a lot of people out there, so thanks for that.
Okay, well, thank you. That's part of what gives me the encouragement to keep doing this, is because it has a positive effect.
Yeah, that's great. All right, Eric, well, I'll try and think out some more intelligent questions, but we can move over to someone else if they'd like to attend.
Okay.
Okay,
thank you.
For that. Hey, if anybody has any questions, go ahead and hit 5 star, and I'll see a little flag that tells me you want to ask a question, and then we don't have a whole lot of people on the call, so hopefully if you are on the call, it's a good time to ask a question. Okay, let's see, if your phone number ends in 155, go ahead and ask your question. You'll hear that your hand is being lowered.
Yeah, hi. This is Abraham Barker. It's not really a question, more as a comment. Looking at Tesla's magnifying transmitter, I notice he likes to work with a lot of voltage-controlled elements. And I believe that his extra coil there was a voltage-controlled element. It was behaving as a trans-inductor thing. At one moment, it could act as a solid conductor, and another moment, it could act as an inductor. And I believe the only way that could possibly happen is if the coil itself was bare metal, because it was wrapped on a rubber insulator. But once the voltage got high enough and there were enough electrons, apparently they would jump between the coils and just go straight up the column. But if the voltage was positive and there were no electrons, then it had to conduct through the metal itself. Therefore, it's a voltage-controlled inductor. Any thoughts on that?
Well, the electrons don't really partake in what's going on here. It's the whole idea is to kind of shunt them out of the deal. So at a certain frequency, electricity ceases to have any metallic connection. Usually about 10 kilocycles is the transition point. So as far as the voltage control element aspect, it's not really, you can't treat the thing as a nonlinear type of circuit element. In other words, its characteristics do not change with the applied voltage. What makes it appear as a capacitor in one one particular aspect and an inductor and another, and for propagation to go around the coil or lengthwise of the coil, is the complex traveling and standing wave distribution on the coil that causes the lines of force to constantly change position and move from one coordinate system to the other. It's a transient condition that has never been mathematically analyzed and is probably too complex to mathematically analyze, even though I've been trying to simplify this subject down where this stuff can be presented either with very basic differential equations or in an algebraic form, but it's not easy. There is a book written on it called Traveling Waves on Transmission Systems that does an admirable job of being able to calculate all these things and algebraically express how they work. But it's a very, 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 those 3 chapters are very difficult. They're not for the beginner at all, and they're not fully developed because the mathematics just basically doesn't exist to define the situation. As far as the insulation goes on the coil, it's best to have the insulation. Otherwise, the corona losses are going to cause complications, and there's more chance that it will arc or burn into the coil form. So Tesla wrapped his conductors very thickly with insulating material. The one drawback of the insulating material is it increases the capacitance and burdens the coil. So there's all these conflicting factors. So that's why it's usually best to use a Teflon insulated so-called conductor, because the Teflon has a very high dielectric strength, yet it's really thin, and it doesn't contribute to the dielectric induction much, and its dielectric constant is relatively low. So the Teflon coating is pretty much invisible to the electrical process.
Yeah, understood. I do have a website with one page on it at abebarker.webs.com that kind of goes over the patent and points out where it could be a possibility, but it's really not a very, very long-lasting option, because I think if the coil was uninsulated, at least the extra coil part, not the primary and secondary, it would corrode, and it would not last very long. So, I don't know. Anyway.
Yeah, that's another factor is you get corrosion on the surface of the conductor, and then that just adds more losses into the system. That's why I always prefer to use silver-plated Teflon insulated wires or coaxial cables with the shield, because the silver is a type of metal. If it gets crap on the surface, it doesn't seem to interfere with the flow of electricity, and then the Teflon around the silver keeps the atmosphere from. Silver is very susceptible to sulfur in the air, so any place you have a lot of diesel fumes or power plants that burn heavy fuels, is the silver always wants to turn black. In fact, actually, you can use a piece of silver and brighten it up and hang it and see how long it takes to turn brown or black, and that will serve as an indicator as to what intensity of pollution you're living in. It's a very good measuring tool for that.
Yeah, I see. Okay, thank you for your time.
That's part of what makes silver work so well for photography, but, everything is digital now, so there is nothing based on real materials or real functions or reality at all anymore. But that used to be... Silver is a very, very interesting material.
Yes, it's very highly conductive, and it falls in the same, period on the periodic table as copper?
I think so, yeah. I mean, it's been a while since I looked at the periodic table, but yes, it's not only is it a better conductor, but it retains its conductivity even when it's marred by corrosion. That's one of the reasons why it's used in electrical contacts, is even if it gets its buildup of corrosion, that corrosion does not seem to interfere with the contact process, so that's what makes it desirable. Otherwise, if you want to use bare material, it has to be gold-plated. Gold has that particularly magical element that it's in direct dielectric contact with the space. There's no intermediate like layer or film or anything that interferes with the process. That's one of the reasons why gold is used in sliding contacts that don't go through cycles like relay contacts do, but just circuit board contacts, because the gold, the surface of the gold always is in direct electrical contact with the environment around it. So when you put two pieces of gold together, there's nothing in between to interfere with the contact. Gold is kind of a magical substance, and that's probably why humans have had quite an infatuation with it over the thousands of years.
Yes, it doesn't corrode. It also is just underneath silver on the periodic table, and it happens to the electron configuration does a weird jump right at that with the gold and silver. It fills up another subshell, for the finishes filling out the previous one. But yeah, it's an interesting group there for sure.
Well, they definitely have their uses. They're part of essential part of the whole deal.
Absolutely. Well, thank you so much. I appreciate that.
If anybody has a question, just hit 5 star.
Hello, it's me again. I have another question on. You might be familiar with Leyland Anderson's rare notes. In that, if you're not, then perhaps you could look at it at another time. But in that particular notes, there's two figures which show the Tesla's tower. In Figure 5, it shows an oscillating electrically charged, and in Figure 6, it shows oscillating electrostatically charged. And basically, the schematic of it, the difference is where Figure 5 shows like a split primary and two secondaries, which feed together a single extra coil, whilst Figure 6 is just your standard primary, secondary, and extra coil. And I just wanted to know what the difference is between that, so those arrangements, and what why have those two different types. I suppose
what was this notebook, or I couldn't quite understand what are these figures in?
Okay, it's called Leyland Anderson's rare notes, and it's just a PDF that's kind of found on the internet. It's only a couple of pages with some other.
So he's put out some more material. I still didn't get the name. Maybe somebody can repeat it for me. What was the name of his paper?
It's just called the rare notes.
The rare notes?
No, like rare as in something hard to find. It's in like rare. R-A.
Oh, rare notes. Oh, okay.
Yeah. Aaron would probably find it for you on the internet, but it's the two different types of show there, and I just don't know what the differences are. It's kind of like you can imagine the cosmic induction system where you've got your two primaries and your two coils driving a single extra coil, and he calls that statically charged, and whilst the normal kind of setup he calls electrostatically charged. So I don't know what he means, why he shows the two differences there, but it's something maybe Aaron could find for you at some point. You could kind of put your thoughts on what you see in those diagrams.
Well, what you can do is you can mail it to me in Lone Pine with your questions about it, and then I can sit down and look at it and then answer you back and send you the details.
Okay, sure, I can do that.
That's usually the best way. When things start to get complicated, that's the best way to interact with me, because then I can just sit right down there and drink a cup of coffee and start working on it, and then write up an explanation for you. So I do that quite a bit. I get quite a bit of mail every month if people have this thing to show me or that thing to show me, and they want my comment on it. So, and I always respond unless it's so outrageous that I don't want to deal with it. But then you get a postcard with a picture of a coyote on it.
Right. All right. I can send that to you and get some more questions as I come up with them.
Yeah.
Also, about your cosmic ray detector, I've actually kind of half built it. Well, I just need to get the relay function in it working. I just wanted to know a little bit about what your thoughts on that device are and how we can utilize it and that sort of thing. I think only myself and Smokey kind of have had a go at it so far, as far as I know. Just wanted to know a little bit more information on it.
Yeah, that was when I had a way to be around the computer all the time, and there was a lot of people on the energetic forum interested in this. I put out about 4 or 5 different experimental efforts to try to get into these areas that very little is known about, and the Tesla cosmic ray is one of those mysterious things. So I came up with a basic circuit configuration that once you got the thing to work on a regular Geiger tube, then you were ready to replace the Geiger tube with other types of tubes or metal plates or whatever to see if this thing would respond to these cosmic rays that Tesla talked about. So I came up with 4 or 5 different experiments. I don't know what they would lead to. It's something that I put out there to encourage people to get into this stuff and learn about it and figure out some way to duplicate this ray receiving system that Tesla has numerous patents on, and come up with something that other than a Geiger tube, which is an ionization methodology, but to come up with something different than that, which absorbs the impact of the cosmic ray. I was proposing using photosensitive surfaces like phototubes and charging them to very high electrostatic potentials, so that if one of these Tesla cosmic rays impacted the photoelectric surface, the high potential would cause the expulsion of it, and then that would cause an overall potential shift and capacitance change that would be picked up by the gaseous discharge detector tube, the OA4G, and then turn that into a relay closure or a click or something like that. The other thing is I had envisioned this with the Geiger tube attached, and I think 2 people managed to pull this thing off. The difficulty is getting the relay to open the circuit so the tube's ready for the next round. That seems to take a little bit of adjustment, but I envisioned it as a popular device that could be sold, where there would be this thing that you could sit somewhere, and every time there was a burst of radiation, it would ring a bell. It seems like people that lived in Japan or people that live on the West Coast, and the jet stream flow from Japan would like having something like that around. So when this bell starts making a big commotion, you know that something's not right. I really think it's a product. I'd like to see somebody develop it. There might be some more modern device to replace the gas tube. The OA4G relay tube is, I think, what they call it. But at any rate, there seems to be quite a few of them around, and they don't wear out. So I would really like to see somebody turn this into a product that's made available to the public. That was what I envisioned with this. I
see, right. Well, I have got the OA4Gs and the P39 or photodetected tube. So I'll dust it off and see if I can get it working again, and see what I can do with that.
Yeah, if you get these things working, make sure that you publish all the information. Other people can duplicate your work.
Sure, I can put it on, but it's one of those things I was playing around with it, and I kind of nearly gave electrocuted myself, so I put it aside for a while until I've got some more confidence to play with it again. But we'll get into it, I'm sure.
Yeah, there's a guy named David Dawson who is on the Energetic Form channel that I initiated, and it appears that he's the one person that really got this thing working really good. So
okay.
that information should be available. I think he lives in Australia, or he doesn't seem to want to write or ask any questions that way. I don't know what the deal is, but at any rate, I know I don't have a computer, so I very rarely ever get to see any of this stuff anymore. And the activity dropped off to a point where it wasn't really worth my while to go somewhere and seek a computer out or somebody's help to get on to ask questions or propose anything, because the interest in this stuff is just completely dried up. So it was kind of a thing for a while, and then everybody ran off into their own hole and hoarded.
Yep.
And so it's kind of like there's probably no more than 5 people, asking questions on this now. It looks like this is pretty much, I expect within a year that this will become a dead horse.
We'll see. Let's see if we can resurrect it, pump some more life into it, perhaps. Okay.
Yeah, I don't
also
know. I put everything I had into it, and and got forward with a lot of things. The physical projects here, and accumulation of equipment, and then once I reached that plateau, things are ready to take off. Everybody just walked away.
Right. I think you mentioned that before. You call it your hydrazone concept or something like that.
Oh, hydrozoan?
Yeah, I think that's how you say it. Yeah, like the jellyfish.
Yeah. Yeah, I forgot what my specific application of that was to describe. Well, I think it's kind of the forces that work against you. So in a jellyfish, There's no central nervous system. There's no circulatory system. There's nothing that really connects the cells. So the organism can only be 2 cells thick at any spot because they respirate independently from the seawater. So the question is, if these cells are all isolated entities, how do they organize themselves into a specific organism? So that's kind of what's referred to as the morphogenic force. So there's some kind of arch form in the ether or something that causes these to organize themselves into what appears to be a unified entity, even though biologically none of the cells have any unification. So it's one of the many mysteries of science.
All right, sure. A friend of mine is working on a project that has uses sound or music sort of based on some of the concepts you've thought of on the Pythagorean temperament and things like that. This guy is making a multiple sound system or multiple speaker sound system with individual amplifiers for individual frequencies in order to to listen to them. And he's trying to develop these so the frequencies are also in the golden ratio sort of arrangements as well. So have you come up with any musical applications for any of your work?
Well, that's actually a big part of what I'm working on. It's usually in reference to to the Earth or seismic or natural phenomena, using the Earth as a musical generating type of system. So it's like the musical seismograph that I was attempting to develop here is to look at graphs on a computer or squiggles on a piece of paper, whatever. It doesn't really tell you anything. It's too abstract. So what needed to be done is we have this very long mine. You can't really say deep, but it's long. It goes about 1,000 feet into the Earth here. It's an XYZ coordinate system, so there's a north-south movement detector, east-west movement detector, an up-down movement detector. So the complication is how to get the signals from the mine in the town. So you have to use carrier multiplex. So the plan was to convert each of the three coordinates into an audio tone, and then use that audio tone, send it through a phone line, and then demodulate the audio tone back into the slow-moving seismic component to move the pens or the oscilloscope screen, the dot on the oscilloscope or whatever. But the thing is, there's no way to really portray all three axes without some kind of, there's this thing that I call the music television that I was developing that might do it. But then it dawned on me that if I make the vertical seismic movement the interval of the octave, and I make the north-south movement the interval of the fifth, and I make the east-west movement the interval of the third, and then, as I normally do with these seismic systems, I operate about 1 million times the sensitivity that they're normally used at by the geological people or whatever. They don't turn the gain up nearly as high as I do. I take it all the way to the level like radar receivers, where the power amplification can reach as high as 10 to the 12th. That's 1 with 12 zeros after it. So what this would do is when it was modulated into the audio to send down the phone line, is it would act like wind chimes. And it would always be making this musically interactive sound that would directly correlate to the complex waveform of the Earth moving. And because the sensitivity is so high, it would be like my system in Landers, where anything happening at all on the Earth makes a mark on the chart recorder or makes a movement on the oscilloscope. So you're viewing the Earth as a single dynamic entity. So if that was converted into this musical coordinate system so that the human mind could perceive the three coordinates without having to turn it into some kind of so-called three-dimensional image, that could really be a very interesting research tool and also be a type of music generator. So the idea was to do this, and then one part would be demodulated to run the actual mechanical seismograph in town, but the carriers would still be available on a speaker to listen to, or possibly three speakers to listen to, and then the plan was to put it on anybody could access it.
Right. Well, it'd certainly be interesting to hear the tones of the Earth, as you might call it.
Yeah, well, the tones would be a representation. So, because the sounds that come out of the Earth are fairly low frequency. That was also a consideration. I never quite got to this point, but I was getting close because the fidelity of the systems that I designed is so high that you could get space speakers and you could connect them through the proper amplification to the pre-modulated, in other words, directly out of the seismic pickups before it gets turned into a carrier. And because I noticed from hours and hours and hours of staring at the oscilloscope at Landers and observing these waveforms is there's a lot of interesting cracking and banging sounds and ringings and other audible noises that come out of the ground. So that was an idea to be one of the outputs. You'd have to use some kind of speaker like a Bose 901 or AR2A or something that's renowned for its low frequency response, because some of the stuff you wouldn't be able to hear, but you could feel it. So there's all kinds of fantastic possibilities with this stuff.
You'd think that people would be interested in that, sort of to help, send some money.
Well, the people
time.
that are interested, are people like you and me, and the other people, that are on the phone line, and the people on the energetic forum and all that. But we all live a hand-to-mouth existence. We can't really push any of this stuff forward. So I because I'm a feral human, I'm free, and I don't have overhead or anything to really hamper a lot of my work. So I have the means to move forward in this stuff, but it's only so much physical output that I can do. So right now, a lot of the outside plant stuff I can do myself, but I need somebody to help me get the ladder up on the pole, and I need somebody or something to haul the ladder. The thing is longer than my car. Otherwise, all the pole work I can do myself, and I need the exercise, and I need to be outside. The problem with the seismograph mine and what have you is it's going to be about $50,000 to build the terminal facility. So that's a big jam up right now. There's no building to put the equipment in. And then my storage facility and office and what have you is I have to pay rent on all that, and that basically burns up whatever funds I have. And then because we have all this outside plant, we're considered a public utility, so we have to pay the same kind of insurance that the phone company and the power company does because of the liabilities, what have you, and the government regulations that we are required to course, or how would you say, comply with. That's a lot of money right there in itself. That's about $24,000 a year.
Wow.
Your funding is... I put it myself just out of my own pocket with my Social Security and savings from it and what have you. I've already put about $25,000 into the outside plant effort. I've been trying to get our financial statement out on the air, so I hope I will be able to do that by this summer. It seems to be a lot of impedance involved in that right now that I'm trying to break through, but we're required to do this anyway. So everybody can see, because a lot of people put money into this, and I put a lot of my own money into this, that to show exactly, where the money goes and how all that works out.
Hi, Eric. Right now, this is Abe. Right now, I'm sitting in a field in eastern Utah. Got my my backpack and my sleeping bag. Just wondering what to do. You accept donations of work?
Yeah, it's providing that you can deal with the circumstances and what have you. So there's the complications. And then what skills do you have?
Yeah, right now my truck is broken down. Well, it's not broken down. It needs new rings. I just haven't bothered to take the engine apart yet. I already rebuilt the transmission, but now the engine needs work. So,
yeah.
Figure.
When you get a vehicle, you really got to just go through. You got to go through all that stuff. Unfortunately, otherwise, you're just in you get ahead, and then all of a sudden you try to go somewhere, and then something else takes a squat. So that's kind of what what stopped a lot of our progress towards the end of last year is you buy a used vehicle and then you go out into these rough environment situations and whatever, and then that causes all this wear and tear, and then all of a sudden it's time for another $1,500 in vehicle maintenance. So you definitely don't want some of these locations where these projects are going on. You really don't want a vehicle to break down.
Yeah, definitely. But anyway, I can donate time if that'd be useful for anything.
Well, it's coming up in late September, and if you got some way to haul the ladder, the line that I have here in this particular geography is not exceedingly hard to get to, and it's within walking distance of a significantly sized town. So that would probably be between you and me, and if you had some kind of roof rack thing or whatever, that we can get this 20-foot ladder out there, we could probably do this whole thing ourselves.
Okay. Yeah, right now I've got a solar panel on top of my truck, but I can take that off. Yeah, I'll have to see if I can get that engine rebuilt or replaced, maybe.
Yeah, if it's time to change the rings, it's also time to change the connecting rod bearings.
True. Yeah.
Yeah, they both have the same maintenance interval. So prefer somewhere between 150 and 200,000 miles if you want to keep your engine at military spec, like I try to do with the Coil. It's rings and connecting rod bearings, and then at 300,000 miles, it's the main bearings and the camshaft bearings, and then preferably the rings and the connecting rod bearings again.
Yeah.
So who makes the vehicle? What's the brand of it?
This is an old Ford F-150 with the inline-six engine. It's supposed to be a really good engine.
Yeah,
doesn't have any.
Pretty basic.
Oh yeah, really simple.
So what year is it?
An 85.
Well, considering the crap that they make today and all the complexities or whatever, it would be money well spent to really go through that thing and make it nice.
Yeah, I think it might be worth it, just because it's so simple to work on and.
Well, that's an important consideration when you get out in the middle of nowhere, and the last thing you need is one of these, fuel injection systems to take a squat on you while you're clinging to the side of some mountain somewhere 50 miles away from civilization.
Yeah, that's true.
So it's important to have basic stuff where there's always some way to get going again.
Yeah, definitely.
I know the guy that does the towing out of Death Valley, and he makes quite a bit of money out of it.
I can imagine.
Whatever outstanding level of stupidity that you display in getting yourself really screwed up out there, he'll get you out. But at any rate, his wallet will be very fat afterwards.
Yeah. Yeah, when you're in desperate situations, people will pay anything.
Yeah.
Are you on any of the mailing lists, or do you have any of the email addresses?
I'm not on any of the mailing lists. I've got your web page.
How did you find out about this call?
Through Facebook.
Okay, so through there you can, if you want to send a private message or something with your contact info, then we can be in touch if you potentially will be helping with Eric. I'm also going to be putting up some type of form or application online that people can fill out, so Eric can kind of go over those and see what kind of experience everybody has. I was going to do that after the last call, but I went out of town, and so I'll be catching up on a few of those things. But we will have a form for anybody to fill out that wants to volunteer.
Excellent.
So I'm sure you'll see a link to that on Facebook. Do you have any other questions or?
Not at the moment.
Okay. Let's see. I'll go and take another question here. Let's see. We're going on an hour and 5 minutes right now. You okay for a few, Eric?
Oh, I can keep going all day.
Right. Okay. Let's see. If your number is ending in 155, go ahead and ask your question.
That's me.
Oh, that is it?
Yeah, I was just there.
Hi. I was 154. Hello?
Hello? Okay, if you have go ahead and introduce yourself and ask your question.
Hey, can you hear me?
Yeah.
Oh, okay. Hi, my name is Robert. Yeah, Eric, I know that I was following some of your videos, some of your information regarding your study of the sun. Is it possible, let me ask this question, a kind of precursor. Were you able to confirm the distance of the sun from the center surface of the Earth and the moon? And the second part is, could it be measured based on the atmospheric layer temperature and the thermometer?
Yeah, I have no way to measure the distance or any time.
Hello?
Basically, it was the ionosphere that I was using as my indication. So I had a very sophisticated RCA dual diversity shortwave receiving system and two antennas that were pointed at right angles to each other. So I had this thing that I called the Earth stereo, where you could hear the echoes and what have you of the signals around the Earth. And then that allowed me to study the atmosphere and how the sun was impacting it in the magnetic field. And then at that time, I was receiving a considerable quantity of material from what's called the Space Environmental Center. Of course, none of this information is available anymore. But I had detailed records of the velocity of the solar wind, the direction, intensity of the interplanetary magnetic field, visual imagery of the sun in several different wavelengths and dimensionalities. I received, every month I got about a 150-page book with all this information, and then there was a newsletter that came out every 5 days with a hand-drawn diagram of the sun showing the movement of the sunspots and what have you. So this was a 4-year study I did at Sonoma State University during an interval in which all the planets lined up. That was October 13th to 15th of 1980. And the equipment provided to me by RCA and the facilities made available to me at Sonoma State College. The objective was to verify the original experiments of the Radio Corporation of America that planetary configurations have a direct impact on HF radio propagation and the ionosphere and a number of other environmental factors. In fact, there was a popular book written on this subject called The Jupiter Effect.
I got that book. I remember you mentioned it.
Yeah.
Well, the thing, what I wanted to refer to is this. I found 2 separate measurements that were taken. One was by NASA, the other one was by the Chinese Academy of Space Technology. They judged the distance below Earth orbit to about 2,000 kilometers. And then I collected several pieces of information to kind of get a median number of what the temperatures were in the thermosphere, which is when you get to the middle, you're at pretty much the high end, and the temperatures consisted in excess of like 1,500 degrees Celsius. but the data that's out there on the surface temperature of the sun is in excess of 5,800 degrees Kelvin. So I, fiddle around with some mathematics to take the vertical distance from the center surface of the Earth, 90 degrees, based on low Earth orbit, factored in what the average distance would be of where the sun possibly could be. Because NASA is saying that the moon, the surface temperatures are minus 253 to 256 degrees Fahrenheit to plus 256 degrees Fahrenheit. Now that's a pretty consistent temperature. Well, those temperatures are consistent around 200 to 300 kilometers above the surface of the Earth. When you take the sun at 5,800 degrees Kelvin, that's in excess of maybe 650, 700, maybe 800 kilometers, which to me, if that's the consistent surface temperature of the sun, then it can't be what they say it is at 93 million miles. And that's how I ended up coming up with some sort of more, I'm not going to say definitive, but it's a better average than what is being put out there in science. Because they're talking about launching probes to go to the sun. But when you're looking at videos and you're looking at data on the Fédération Aéronautique Internationale for highest altitudes and distances, and I look at video and I compared videos of every space shuttle launch, every time I look at the telemetry data, I see the space shuttle disconnect from the main fuel tank at 350,000 feet above the surface of the Earth. Now, I want to know how it is, based on what we know about acceleration and velocity and speed, how it is something can travel at 16,000 miles an hour, disconnect from this large fuel tank, cut its engines off at 350,000 feet, and then have to travel another 130 to 140 miles to something they claim that's 250 miles away, in geosync orbit, traveling at 17,000 miles an hour, the size of a football field, 100 yards long, 50 yards wide. That just doesn't make any sense to me, because there's atmosphere up there. And if the ISS is losing 1.2 miles every orbit, and so would the space shuttle once it got at its velocity, and it has to gain another 1,000 miles to catch up. It's just, to me, the way things are looking with regard to the moon, the surface temperature of the moon, it has to be, for me, when I did the math, I got a mean distance of somewhere between 62.5 to 68 miles. 68 miles. And I've also been doing research on Dr. James Van Allen. He claimed to have launched a 3-foot rocket on a balloon from the University of Iowa in 1957. And somehow this rocket got to 2,400 kilometers from the surface of the Earth in Iowa, from the football field, to measure the Van Allen belts. And this is all in his papers. So at that time, in 1950s, the U.S. Naval Research Laboratory, they drafted a report doing upper atmospheric testing rockets, and nothing got beyond 73 miles. So how could he go to 2,400 kilometers with a 3-foot rocket? See, a lot of this, I've been doing a lot of your research, comparing it to a lot of things Tesla's doing. I mean, everything that you're saying is fantastic. But the problem I'm having is that the information that's put out there in the mainstream academia, it's not consistent. You got the Chinese saying that low Earth orbit is 2,000 kilometers, but you got NASA saying that low Earth orbit is at somewhere around 800 kilometers, 100 kilometers. They can't even agree with each other.
Yeah, it's kind of like we're not really being provided with accurate information, and or their measurement concepts, or what they don't really know what they're trying to measure. A lot of this stuff, like the sun, we have no idea what dimensionalities or coordinate systems exist inside the sun, and we'll never know. hollow sun concept presents itself in that situation. And then when you get in outer space, you can't see any direct light. It's only reflected light. So then what is light? The velocity of light seems to be questionable. All my Steinmetz books say the velocity of light is 188,000 miles per second, but we're told that it's 100. It's less than 184 or whatever. I can't remember now because I always use metric. But
would you agree that the sun is still within our atmosphere?
What's that now?
Would you agree then that the sun can't be in free space and it's somewhere within the exosphere and it's reflecting off of the rest of the gases and whatever particles that are inside our atmosphere and it's not in free space?
Yeah, well, apparently the primary emission from the suns and the stars is not light. It's something else. So that means that the velocity of light would have no meaning because it's not light. It's only light when it comes in contact with physical matter, and then that's kind of how it presents itself to us anyway, because, you can have a light bulb hanging on the ceiling and it's lighting up the page on the table, but it's not lighting up anything in between. So there's all these inconsistencies, and then if you want to get a perspective in all this, I really recommend going back and reading E.T. Whittaker's books on the history of the theories of ether and electricity, and you'll find out that the science of optics was a very convoluted thing during this scientific age, if you want to call it such, in the 1900s. And there's so many inconsistencies and experiments that didn't correspond to equations and concepts. It seems like basically what happened is after about late 1890s into 1900 that everything actually started going backwards.
Okay.
Until now,
I would agree with that.
Now it's just gibberish. It's like we were on the internet the other day, me and one other guy that's part of my organization here, searching for grants. So he was on the internet and I was on the telephone talking to him. And, these various people that do this earthquake and geological research and all that is the language is so wordy and beating around the bush and so overly complicated and abstract and symbolic that it has no connection to reality whatsoever.
That's exactly what Nikola Tesla said. That's exactly what Tesla says. Scientists fiddle around equation after equation, trying to develop some sort of construct that has no relation to reality at all.
No. The thing is here, I'm a professor on the subject, and my whole life since 6 years old has been devoted to electrical transmission and experimentation and research into electrical transmission, whether it be radio or wireline or whatever. And by the time that I graduated from high school, I was a licensed radio engineer and was a competent electrical engineer, and felt this confidence that, it's all so explainable, and all you have to do is just go run back to Maxwell's equations and you'll find an answer. But that's not true at all. Those things are just projections and shadows of what's really going on. And then in putting this presentation together, and in my most recent studies of the transmission theory, is probably one of the high priests of transmission theory and network theory is a man by the name of Ernst Gilliman. And he really brought the thing to, how would you say, kind of like a level of conclusion and understanding and unification. And in his introductory chapter called The Engineering Solution to the Long Line Problem, he points out that there are all these modes of electrical propagation in the boundary between the conductor and the dielectric that have just simply been left out. And then further that the differential equations that we all parrot and that all transmission engineering is based on, the second-order differential equations, are only two terms of an infinite series. So Tesla worked strictly by experiment at a time in which everybody was experimenting, and it was all very interactive. You can't say that Tesla discovered this or Thomson discovered that or whatever. These people all worked very close together and influenced each other. And in the course of these experiments, the one thing that set Tesla ahead of everybody is Tesla was an electrical engineer and the rest of them were academians. And because Tesla was an electrical engineer, he could perfect the apparatus far, far beyond what any of these university professors could do, because they were still fooling around with stuff that Faraday cooked up. And so they couldn't make the discoveries that Tesla made. So Tesla was using this type of electricity called impulse current, which is basically the mirror image of direct current. It's quick, abrupt transients. It's not oscillatory. There's no sine waves. It's just it's there and then it vanishes. And then when you make reference to Ernst Gilliman's writings about these surface waves and the radio work of Reginald Fessenden, who was surface waves, and the radio work of Massey, who was broadcasting or transmitting through the magnetic lines of force themselves as a medium, like wires, Tesla, through his experiments and the waveforms he was using, quite possibly discovered modes of electrical transmission that are just completely neglected. You can't say, oh, well, Tesla was just, it was just radio waves, or it was just electrostatic fields, or it was just this or just that, and we can go, with Ohm's law and geometry and all these things and fit everything that Tesla did in a strange way, but fit it into conventional understanding, but that might not be the case. If you see what I'm getting at.
Yeah. Eric, I wanted to, because you deal with a lot of signal propagation, and I wanted to touch base with you on this because I had a conversation with the head of cardiology at Johns Hopkins. This was quite some time ago. I'm working on a project. I had been working in the Navy for quite some time, and I was an anesthesia tech working with the anesthesia cardiologist. And my research for the past, I'd say, 10 years has involved capturing a specific neurocardiac signature and identifying the signature patterns of the sensory neurites in the human heart. And what I found out when I started diving into electromagnetism is that the heart emits its own electromagnetic field. That field becomes stronger in colder temperatures. Which means that for me to conduct any sort of field testing, I'd have a higher rate of success, conducting this experiment in colder temperatures. Now, I also went into the realm of, looking into advanced Wi-Fi and turning current Wi-Fi into a biomedical measurement and signature intelligence device, whereby instead of it picking up radio frequency signals and transmitting them, it would actually pick up the specific signature that every single human heart gave off from the SA node. The SA node is the first electrical spark actually functioning within 3 to 4 weeks of conception. It's the first signal present in the human body. The heart hasn't formed, the brain hasn't formed, none of the other neurological systems have formed. You just have this small piece of fibrous neurological tissue firing on an oscillator, on a echograph, creating the sound that you would hear when when a mother's pregnant 3 or 4 weeks. So my thought was this: it took me into another area with regard to the resonance of the sun and what that frequency was. And a lot of the research I've been finding out is that the resonance, the sound and signature of the sun is nearly identical to the same electromagnetic field signature of the human heart. And then it took me into another area regarding the electromagnetic field supposedly around the Earth. And being in the Navy, I discovered something interesting looking at the National Oceanic website in USGS, is that the further you sail outward, away, out from large land masses, the colder it gets. The colder the air temperature and the water temperatures get. So could it be possible that the further you get out from land masses, in every which direction from the center surface of the Earth, out in the waters, we know that electromagnetic strengths and fields increase in colder temperatures and decrease during warmer temperatures. So what could be providing this sort of cryogenic environment out away from the land masses where the temperature gets colder? And does the landmass and the gravitational anomalies on land have anything to do with stabilizing the inward temperatures and creating sort of a thermal equilibrium environment layer between the surface centers, and you have a median layer between the outer layer, which is much colder, but no one really knows how cold it could actually get, because no one's ever ventured out that far. Does that make any sense? Because sometimes I get out in these things where everything starts to branch out in all these different directions, but I know for a fact when I've seen, and I've been in the observatory deck doing open heart surgeries, they put the heart in a cryogenic environment. They pour saline inside the chest that's been frozen, that's been dropped down to a particular temperature to literally slow down all of the activity in the human heart. And literally, when they are finished what they're doing, I've seen cardiac surgeons just basically flick the heart like they're trying to test for the ripeness of a watermelon or a cantaloupe, and it immediately starts with no paddles, no electrical, jump starter charge. Some patients require an electrical jump starter charge, but I found out that the SA node could literally, the entire electrical activity of the heart could be restarted with a 9-volt battery. A 9-volt battery. You don't require 100, 200, 300 joules of electricity. You can get it started with a 9-volt battery.
Yeah, well, that makes sense.
I just wanted to hear. I just wanted to hear what you
that the heart is operating on anyway. So, they hit the thing with a half an amp of electric current. It doesn't sound necessary. That 9-volt battery, in a conductive environment like that, actually puts out a rather substantial current. It's not surprising.
Yeah, exactly.
Restart the heart. Probably even a smaller quantity of electric charge would do it. It'd be interesting in the experiment to see what the minimum electric charge is. Otherwise, what you're talking about is kind of outside of my field, so I don't know exactly what to say, but it's quite evident that things are a lot more complex than we're led to believe, and to use the term electromagnetism is not really correct anymore, because electromagnetism is just one very isolated coordinate and dimensional reality, and there are so many different fields. You can turn to the work of Wilhelm Reich for that, and his orgone, and the electrostatic researches of Nikola Tesla, and the stuff that Ernst Gilliman talks about, and whatever, and Electromagnetic.
Did you say it's You said it's electrostatic. It's electrostatic, not electromagnetic.
Yeah, Tesla's technology was all electrostatic. Electrostatic's not really the right word. Steinmetz sought other terms, and he called it the dielectric field. But there's a certain complication with that because the dielectric supports both magnetic and electrostatic induction. So it's to come up with a language to describe this stuff can be rather difficult. That's one of the immense difficulties I have in writing my books and presentations is to keep a consistent notation, because particularly with the Versor algebra book, because the electromotive force E has so many different configurations that it's very difficult to come up with any kind of sensible arrangement that doesn't have such a clutter of subscripts that you can't visualize it anymore. So that's another complication, like in the transmission books I'm writing, is the word voltage has no meaning. Current does, but the word voltage has no meaning. And that's something that's not understood, is the term voltage.
It's interesting to hear.
Go ahead.
It's interesting to hear that from an electrical engineer. I said that to a professor who was teaching a physics course I was taking, and it pissed him off for me to
Physics is a denial of electricity. So physics fancies itself as having the absolute knowledge of the eternal and infinite universe, and all it is a big masturbation process. There is no science of electricity anymore. It died. All that died when Einstein came into being. Is electricity was basically pronounced dead. And if you try to get funding in any of these areas, like I'm working on with geological, or in your case, life sciences, or any of that type of stuff, and you try to equate what's going on to an electrical situation, you're the bad guy. You're not supposed to. There is no electricity. Everything is thermodynamic and mechanical. And so situation, everyone parrots voltage. You can go around and ask 100 people, some of who are supposed to know and some who are not supposed or wouldn't know what voltage is, and everybody will give you a different answer, because his voltage is just it's a dimensional construct. It's a bottle to put, it's to put something in. So you either have electrostatic potential or you have electromotive force. And electrostatic potential and electromotive force are two very, very, very different things. And it's the same thing with current. You either have conduction current or you have displacement current. And again, those are two very, very different things. And in the book that was originally called Lone Pine Writings, is I make a very forcible attempt to clarify that issue and to come up with the proper notation that separates these four terms, because electricity is always a fourth-order relationship. It's not a second-order relationship. It's a fourth-order relationship. And to express it in a second-order relationship is just to look at the shadow of it. And unfortunately, the physicists, in their ignorance of the subject, have just petrified everything. I struggled for I don't know how many years to answer a very simple question, is what ratio of electrostatic potential to conduction current in a two-wire transmission line will cause the magnetic force, which is pushing the wires out, and the dielectric force, which is pulling the wires in, to be equal, and then there's no net force on the wires. And I struggled with physics books on that, and the result was I threw them in the garbage.
Eric, you got me thinking really deep just now. I want to ask you this, and I know that this is crazy, because everybody, and Erica, out of anybody, there are people out there trying to create perpetual energy systems, okay? And you just got me thinking about something that was shared with me by an MIT professor, and he sent me an equation. He sent me Planck's equation on black body radiation. And this is my thought with regard to electricity. If you have an electrical current flowing through a cable, which is encompassed of several different other wires. And you're able to not only get that energy and that power from that current being generated, but you're also storing the black body radiation that's being emitted from that cable and having it stored in another system inside some sort of device whereby when the electrical current is cut off or extended, you now switch to the black body radiation that's been stored to use for backup energy. And I'm not sure I listened to a lot of your videos, read a lot of your information. I'm not sure if you had actually mentioned black body radiation before, but this is something that was introduced to me a few years ago, and I'm still studying it. And it just became really interesting because I had been working on this technological capability with Wi-Fi, and I was missing something in a lot of the math and the algorithms that I was putting together. And someone said to me, hey, you might want to look at this. And it was this MIT professor, and it blew my mind, because when I started looking at the math, I'm like, wait a minute, everything emits some sort of black body radiation. Even a spoon that you just touch with your own hand and placed on a table, with the right calibrations on a thermal imaging camera, you'd be able to pick up the level of black body radiation that spoon is actually emitting at that particular moment when you let it go and put it on the table. And I got the same idea when I started looking into, we started discussing, in the classroom, how you could literally become more energy efficient by using the energy that was being created to produce to capitalize on a secondary form of energy that was being emitted by the creation of the original source, which was black body radiation. Just wanted to hear what you had to say on that.
Well, it's kind of a little bit out of my understanding. So for me, black body radiation is something that I have to deal with in microwave antennas and particularly any kind of outer space communications. But it sounds kind of sounds like what's going on. The black body radiation, from what you might be saying here, is always being emitted, even though it can't be accounted for by any particular thermodynamic input that was stored by that, then is emitting the radiation. Now, the thing with currents and cables and all that is a current just a shadow of a magnetic field of induction. So a current comes about by magnetism being basically consumed inside the conductor. So I put together, I deciphered a lot of J.J. Thomson's work on that, and I put that out on the internet. It's presently out in what we refer to right now as notebook number 4, because none of this is being transcribed or published, but the Thomson theory of how conduction current comes about and the relationship with magnetism. And then Thomson asserts that magnetism also is a secondary, and that it's actually what he called the Faraday tubes, or the ether lines of force, which are basically electrostatic or dielectric in nature, and showed that everything basically evolves out of these tubes of electric induction, and the current flow in the conductor is an end-of-the-line situation. Years ago, I used to give the analogy is current is the footprints in the snow of the invisible man.
I like that.
Invisible man, you can see his footprints, but you can't see him. So how do you see, or we have to use mathematics and special test devices and what have you. Simple compass actually works quite well for a lot of stuff.
Yeah.
To measure these things, but all this is so much more involved than than this modernistic interpretation. That's what inspired Thomson and Tesla and Heaviside and all these people is, Tesla, came right out and said that electricity is Aladdin's lamp. And that was the premise in my last presentation, is the ether can't be pinpointed to some specific material or configuration. Exactly. The ether is what you ask the ether to be.
Exactly. It was what Einstein and Planck said about quantum consciousness. When they all agreed this is what the outcome would be, it would be. But if there was one person who doubted it, it would not be the outcome they were expecting. It is what it is. That's that coin the phrase. Last question there. Do you believe that there's like a dipole or north and south pole, or is there one single pole, a magnetic monopole that just shifts or rotates?
With reference to, you mean the Earth's magnetic field?
The Earth's magnetic field. Do you think that there's two separate poles or just one single magnetic monopole that just shifts every now and then?
Well, I pretty much have it visualized as a pair of poles, because magnetism is a closed-loop phenomenon. So a magnetic monopole is kind of a difficulty, even though the Tesla transformer kind of simulates such a condition, because you can have a current at one end with no return line, and you can have a potential at the other end without any reference to ground. So that makes one end a magnetic monopole and one end a dielectric monopole. So I suppose if you were to extend that to the Earth, you could have a pair of those. So then you would have to have four poles. So the Earth has a very predominant electrostatic field. In fact, there's probably more energy stored in the electrostatic field of the Earth than there is the magnetic field of the Earth, except right around the poles, which is,
okay.
If you have any receiving equipment, like these long line antennas I built where you can hear every lightning strike on the planet, I mean, this stuff's in a constant roar. That's a lot of dynamics, that's a lot of,
wow.
A lot of 50 microsecond, 50,000 amp, 1 million volt discharges, and they're at a constant rate. And then there's these auroral electrojets. So around the poles, there's a current flow of about 25,000 amps in the upper atmosphere in a big ring around the poles, which basically is a giant inductance coil. So in all probability, that's where the Earth magnetic field originates from. This concept of some bar magnet inside of the Earth is pure garbage. I mean, first. So
do you think that
there's what's called the Curie effect, and if you take a piece of iron and you bring it to an incandescent temperature, iron has no more magnetic permeability other than that of the ether itself. So if this theory of the inside of the Earth has all this molten stuff and the temperature is all high and all that, which I don't believe anyway, but you can't have a bar magnet inside the Earth because it's too hot. None of it makes any sense. The Earth's magnetic field is generated by the electric induction from the sun, just like the light on the Earth and the heat on the Earth is generated by the electric induction of the sun. And what that electric induction from the sun is becomes completely indeterminate when you get into a mass-free environment like outer space. And then if there's no light and no electromagnetism directly, then this whole notion that it takes, 10,000 years for the light to reach us from some distant part of the universe doesn't make any sense. So it's only when it gets converted to electromagnetism does that velocity present itself, and then the velocity of light is just an abstract anyway. All it is the square root of proportionality between the total amount of magnetic induction and the total amount of dielectric induction at any given point of space, and it's not a velocity at all.
It's just static.
It's just a dimensional relationship. It just happens to be, I hit on this real heavy in the presentation before last, is how did this understanding of Maxwell and the velocity of light come about? And basically, it's just a proportionality factor that exists between the magnetic field and the dielectric field that gives you the dimensions of 1 over velocity squared, which happens to numerically and dimensionally equal 1 over the speed of light squared, but it's not the speed of light. And the thing I hope to point out in this next presentation is when you start doing transmission studies, you can get yourself in real deep trouble in your calculations, assuming that the propagation velocity is that of light in that particular medium, because the lower you go in frequency and you start getting close to DC, the propagation velocity goes down and down and down. So if you have a 25-cycle power system, like for a major electrical railway, and you're using conductors that there's no skin effect because the frequency is so low, and that the full conduction is taking part in the metal, the velocity of propagation is only about 10% that of light. And when you get down to direct current, there's no propagation velocity at all. So there's basically no theoretical understanding or justification for how direct current can even exist.
Wow.
So there's all these open-end situations that just simply aren't addressed anymore. When, in the days of Steinmetz and Kennelly and Heaviside and all these people, these things were still being considered. But now it's just it's gone. I don't even think I would go so far to say that electrical engineering itself doesn't even exist anymore. The stuff that I see going on in the power system, for somebody that was spoon-fed on this since the age of 6, to me is absolutely appalling. It's almost pornographic.
Yeah, I'm not an electrical engineer, and I know very little about electricity because for the past half a decade I've been dabbling in Wi-Fi and been fascinated with that, and got access to some data that I had to sign a non-disclosure for with Intel. I wanted to understand how their advanced Wi-Fi adapter worked. What did they do to, change the specific, power structure and transmission speed. And in the process of doing that, I ended up downloading MATLAB Signal Processing Toolbox, started to fool around with the adapter to literally overclock the capacity to the point to where it sapped my battery in less than 30 minutes as soon as I plugged it in. But the range of the signal that I actually transmitted and received, because I was conducting, just a little small test to see how many different biophysics signatures I could capture from, say, maybe 50 yards. And I was looking out the window of my home office, and every person who walked in front of the window, I was picking up signatures. I mean, there was nothing else passing in front of the window. There wasn't any dogs, cats, or animals, or birds, or anything like that. But I had already programmed in knowing exactly what that human signature would look like, and I just wanted to see what it would do. And there was a group in the U.S. called Incutel. They actually drafted a paper behind a research paper I drafted on the university level for IT security measures, countermeasures, and it's titled Exploiting Physiological Intelligence. And it's basically the same concept. When you turn on your computer and you look at the Wi-Fi icon on there, you'll get a list of every single Wi-Fi connection that's within range of your own system. My system is the same exact way, but instead of seeing computers that are plugged in, you see people. You see the physiological intelligence signatures of people. You click on one of those, and you'll be able to read the physiological electrical intelligence of that particular individual on a biophysics level. I mean, it's just interesting. I mean, I'm having to go into all these different directions, and I just can't stay. If I were just to focus on cellular biophysics, that wouldn't be enough. I'd still be missing something. And, I'm starting to look around me to see that, things that are happening every day on the so-called physical level, or giving me answers and solutions to some of the, not problems, but ingredients that I need to continue to add to this entire system in of itself. Because there are certain people, what I'm finding out, that are actually developing negative health effects to the exposure of Wi-Fi.
Well, yeah, I did research on that years and years ago, and that stuff is not good. So
yeah, but here's the thing.
It started with basically in my childhood experience with Bell Telephone, I was taught, safety procedures and standards of exposures to those particular wavelengths, which range between like 30 centimeters and 10 centimeters, and accordingly protected myself from exposures to this to what today would be considered a fanatical degree, because all those safety standards have been dumped in the toilet bowl. So there was a point in history, I think it was around 1969, that the American embassy, I think it was in Moscow or something, it had been determined that there was a 400 megacycle carrier wave that was being broadcast through there. It wasn't particularly powerful. The purpose of it is what you do is you listen to the echoes that come back, and the vibrations of physical objects in the room modulate the radio waves, and you run it through a phase comparator, and then you can hear what people are saying inside the building. Today they use lasers.
Yeah. That's what you're talking about.
So at any rate, everybody was getting sick, or there was something that made this a famous story in its time. So the woman that was running the science department in my high school knew that I had a Bell System TD2 microwave system in my laboratory in my parents' garage. So she showed me an issue of a magazine that was popular amongst science teachers and what have you. I think it was titled Science or something like that. And they had discussed this Soviet thing, and they had done some experiments with milliwatt levels of these 30 to 10 centimeter wavelengths. In this case, it was the frequency I was using was 4,000 megacycles. And she wanted me to duplicate the experiment, to bring the stuff to school and set up a laboratory away from the rest of the students. So, the principal was all concerned about radiation and stuff, so they set me up with a laboratory. And sure enough, no more than 10 or 15 milliwatts of exposure of those frequencies to radish seeds produced radical changes in germination and growth patterns. For only 15 minutes of exposure, and now human exposure to these particular wavelengths is orders of magnitude greater than that. Particularly, your silly phone. So you're holding this thing right next to you. I encouraged some people once to do an experiment, take radish seeds, and back when these things still had external antenna on them, and tape them onto the antenna, and then motor mouth on the phone for a couple of hours, and then take the seeds and plant them side by side with the control seeds that are kept in some kind of thermal environment, which would be the same temperature. That's what we did, and see what level of mutation this stuff causes. But this Wi-Fi thing now has just created a complete saturation of centimeter wavelength interference, and it's interesting.
That's interesting.
You're using sonar to examine the body, which is interesting. That really doesn't have much to do with the digital end of it, because you're dealing with the radio waves themselves and not the modulation, but maybe the spectra of the digital. I'd have to kind of see what it is that you were doing.
Yeah. That's something I'd love to share with you at a later time privately. Because I was speaking with an associate this past weekend. The sun gives off supposedly electromagnetic waves, similar to what it's Wi-Fi does it artificially, of course. But I found a National Institute of Health study, that broke down the effects of skin cancer in race and ethnicity. And the results and findings were incredible because it allowed me to do some more research to find out if the National Institute of Health did research on electromagnetic wave propagation and how it might have affected race as well. So I took the two studies and I found out that electromagnetic wave from cell phones and other types of electronic devices have a negative effect on people of low melanin count or fair skin, whereas people with a very high melanin count and dark skin, African, black people, they can absorb the UV radiation, electromagnetic wave radiation, and it doesn't have any kind of ill or adverse effects to them physically at all. And it has nothing to do with the fact that they can't afford to have computers all over their house and cell phones and so on and so forth. But the study involved, the same equal group of, different ethnicities and races. And they all use the same devices at the same level. And there was literally less than 1% adverse effect on the higher melanin count of people versus fair skin and Caucasian. So it dawned.
I have a complication, when I do outside, work and what have you, and if you use plastic wire ties that are white, they have no life whatsoever. Particularly at the altitude or here, it's just the sunlight just destroys them. But if you use black wire ties, they're not affected, which makes sense because the black basically just kind of short circuits the whole thing out. There's no depth of penetration for the radiation to get in, where if they're, kind of quasi-clear or white, the radiation can get right in and then destroy the molecular structure of the plastic.
I thought that was really interesting where, blacks can absorb UV radiation. It makes their bones more dense and stronger, and it has the exact opposite effect.
I wouldn't say that they're absorbing it, and I would say more that they're shorting it out. It can't propagate.
Well, on a physiological and anatomic comparative level, blacks do have a higher bone density and body mass density than their Caucasian counterpart. The medical research, tries to explain why this is, but when you throw the sun into it, and we all grew up saying, oh, you need to have some sunlight, it's rich with vitamin D. Well, that's the same thing, they're claiming, hey, drink your milk because milk will help your bones grow stronger. We all were told this when we were kids, but you get it naturally from the sun. I mean, for example, when my son was born, the first 6 hours of his life, the first thing the nurse told me, hey, go walk outside the room, the sun is out, just stand up against the window, let the sun shine on him so he can get some color, and absorb some of these vitamins. And this was something I had already known, because I worked in a hospital on a pediatric ward, but it gave me that time to think, like, wow, I need to start doing some more research into, what I'm doing on the advanced technical level, because now, I've got to be more cognizant of, okay, what's the environment doing? How is that going to affect what I'm going to develop on the hardware, software, technical level with regard to signal transmission and receipt? And, I know there's probably other people who want to talk and ask you a bunch of questions. I'd love to share emails with you. If you don't do email,
I don't have the email, but you can always write me at my Lone Pine address.
Yeah, I have that address, and I'd write to you, and then we can have a phone conversation. I want to share with you the algorithm because I had to have a German test and measurement company develop, custom engineer one of their advanced oscillators where I needed them to remove a piece of hardware that would allow me to capture this signal on the measurement and signature at a level. And they got really interested in why I wanted to do that and said, hey, we'd like to talk to you about this. What are you working on? And I'm like, for right now, can you do it? Just let me know if you can do it. So I'm heading into the final stages of putting the prototype out there, and once I have that, I'd love to share it with you so you can kind of reverse engineer it and tell me what you think and how it could be made better or how it could be made multi-purpose in several different areas, because NASA JPL out in Pasadena became interested in the algorithm, shared it with their signals lab, and the first question out of their mouth was, where did you get this? What are you working on? And I'm like, nothing. Did you validate it? Yeah, we did validate it. This is incredible. What, you want to talk to us? No, I don't want to talk to you. Thank you very much. And that was it. Never spoke to them again. But they ended up creating something similar to what I'm working on, and you can find it on the internet. It's called the Finder. JPL. It's called the Finder. Now, what they developed is about a carry-on size, suitcase size device, and it's got it's a hot mess. What I will put out in the field will be the size of a credit card you can plug into a laptop. And actually, it'll be the size of like the USB key from your wireless mouse you can plug into a laptop. That's how big it'll be. That's how big it'll be. What they developed is just a box of garbage. But they developed it based on the paper that was shared with them on the university level. So, Eric, I want to thank you very much. I mean, I've been watching your videos, listening to you a long time, and I couldn't believe I was going to have this opportunity to actually ask you a question, and it's an honor. I'm going to continue to follow you. Stay healthy, stay strong, and I look forward to, speaking with you further and exchanging brain synapses and neurons. Thank you very much.
Well, thank you. It sounds very interesting.
Take care, sir.
Hello. Good evening.
Yes, go ahead.
I'm from the Netherlands. But I discovered your work 2 years back, Eric, and I want to thank you for that. I first saw your video history on electricity, and then later the origin of energy synthesis. That's a real great one. I think I can follow it almost completely. And then, the four-quadrant theory also was nice. But I want to ask you if you are familiar with the work of Konstantin Mel from Germany.
Okay, did you ask a question or?
Yeah, he asked if you're familiar with the work of Konstantin Mel from Germany.
Yeah, it's going the wrong direction, completely wrong direction.
Okay, I thought he did this experiment, which I put it on the video, also on the old videos where he did the faster than the relativity ticket. That's a real great one. I think he does the same thing with 1.5 times the speed of light in the experimental kit he sells. But you say it's totally different.
Yeah, it's not, what he's doing is confusing the whole situation with Tesla and kind of profiteering off of devices that used to be available to any high school science department from Edmund Scientific. So he's not. There's no knowledge on Tesla's work to be gained from him. It'll lead you in the wrong direction.
Okay. Well, thank you for this opinion. I'm still studying the thing because I discovered his work last year, and I thought it was the same phenomenon because he both did the same Tesla experiment, I think. Also, the thing you did with sending, in one of your Borderland videos when you sent out of in the field with pancake coil. I think
that was out at the RCA antenna field. I was grounded to one of the giant 1,000-acre ground systems out there. So that was to demonstrate the coil, and then also we used the fire hydrant in the water system in town, which is buried right in the San Andreas Fault, into the ocean, and it pretty much showed without a doubt that the transmission is possible tellurically inside the Earth without any kind of antenna. With this Michael Constantine guy, he completely misses that, and he's trying to explain everything as an electrostatic transmission. But that's just incidental. It's the telluric transmission is what Tesla was really doing. Anything that Tesla did through the atmosphere usually was in the terms of some kind of beam or ray, and was never just the electrostatic field by itself.
Okay, well, I think, the word scalar wave, which Constantine refers, is what he means actually is longitudinal wave, but it has to do with the mathematical thing of the third Maxwell equation, and then, that comes out to be a scalar, I think, instead of the vector thing. But he says that the third Maxwell equation is not equal to 0, and they also did an experiment in 2009 in Berlin, which he refers to, where they found this monopole, which you just were talking with the other guy, which was for me. But,
yeah,
so they discovered actually the monopole.
Yeah, well, that's basically what's going on. It's a monopolar situation. That's correct.
Yeah, so I think Constantine, he described all these things also. He wrote a few books about the potential problem. Well, I think if you study some of his work, you have another opinion about it, so I'll leave it at that. And then I have another question, if there was still some time. Also, the guy, Bruce De Palma, I discovered his work last year, but I think you are not really consistent with Bruce De Palma, because I saw your video from '96 where you were on this, how do you say that? Electronic radio thing?
In Santa Barbara.
Yeah, and then,
Yeah,
and then somebody asked about Bruce De Palma, and they said that it was nothing.
Yeah, I personally knew Bruce De Palma, and he was just glomming on to somebody else's work that became lost and was never fully understood. And I never saw much of anything worth pursuing in Bruce De Palma's work.
Okay. Well, there was this guy in India, Tiwari. He has this device apparently. He also worked together with Bruce De Palma. Well, there was a movie in Austria also about Mr. Tiwari. His name is, I don't know if you are familiar with his work. If you type in tiwari.org, he worked together with Bruce De Palma. But you say this whole device about the M-machine, it's nothing.
Well, I mean, he may have shown that the law of conservation of energy doesn't apply. But other methodologies did that too, such as that what they called the reluctance machine, the electrical generator that I did the tests on in the video, that first Borderland video.
That's great. When you show the two cycles of electricity, yeah.
Basically, that to me that was the right direction to go. Is some kind of alternating current parametric situation, and the efficiency of that thing was no worse than 100%, which is already theoretically impossible. I measured the efficiency within the error of the instruments to be greater than 100%, probably somewhere between 104 and 108%, and a machine with that much leakage inductance and that much resistance due to its small size and core losses due to their abrupt waveforms should have never been any more than 50% efficient. So I've always advocated parametric conditions where you're varying some circuit parameter with respect to time was the way to go, and I'd encourage people to do these experiments with magnetic amplifiers. And in fact, I pretty much backed somebody to do this research, this John Polakowski character, to pursue this stuff, but he just basically ran off with the money and never finished anything. But that material is in safekeeping. The thing is, I can't do everything myself, so I have my own specific games, mostly which right now are writing, and then this long lines and telluric research. So I always try to encourage other people to pick up on this stuff. I've written enough material on it that anybody with reasonable technical knowledge should be able to carry through in these things.
Well, Eric, I think I'm not 33 years old, so I will experience this period probably, but we shall see. But I want to thank you for your answers, and I will follow your work here from the Netherlands to the internet. So I hope you will keep that post alive, so I can follow you from the Netherlands. And thank you, and a good day.
Thank you.
Okay, I didn't quite get the last.
Yeah, he was thanking you, Eric.
Okay, you're welcome.
Let's see, what's on 2 hours and 13 minutes now? We can probably go ahead and wrap it up unless anybody has a final question. If you type star, and we'll take maybe one more question, and then we'll go ahead and finish the call. If you hit 5 star, that'll let me know you have a question. And if not, some of you joined the call a little bit late after we started. Eric is going to be presenting at the 2016 Energy Science and Technology Conference. That's in July 8, 9, and 10, coming up this summer in about 3 months. You can find details at energyscienceconference.com. Also, if you would like to help support Eric's work at UPD Laboratories, which is a 501c3 charitable nonprofit organization, you can make donations through PayPal or by check and money order. The address is in the right column of Eric's website at erickeydollard.com. And do you have any final announcements or anything, Eric, before we go ahead and finish the call?
No, I think we pretty much exhausted the subjects.
Okay. The call from last time, which was on March 27th, I have that up on YouTube. I'll send out an announcement with that link, or I'll actually post it on your website so people can listen to that. This call I'll try to get up here pretty quick. I don't know. It's 2 hours and 14 minutes, so I don't know if I'll be able to do that today. But within the next week, I'll get this up on YouTube, and I'll make that link available as well. And so I guess with that, thanks everybody for being on the call, and thank you, Eric, for your time, and we'll announce next time we have another call.
Okay, sounds good.
Okay, yeah. Thank you.
Okay, thanks a lot, everybody.
Thank you.
Thank you.
Thank you.
Thank you. Thank you. You're all welcome.
Thanks, everybody.